Hey guys, I am Gautam from IIT Kharagpur and welcome to GChemix. In this video, I am going to talk about what topics should you revise in this 3 days left for IIT Jam 2019 examination. Okay, so I will cover the whole syllabus and I will say what should you revise. Okay, so for the particular examination. So the first, that is from physical chemistry. The chapter is basic mathematical concepts. So just do practice the basic things. That is what is the condition of maxima, minima, just basic conditions. Then the differential equation, just know about the just normal differential equation. Okay, for example, which is the circles equation. Okay, so these kind of things. But basically solve matrix and determinants, because in every year I have seen that questions from matrix and determinants come. That is very important actually. Okay, so this is important. So just do basic functions and the maximum, minimum, then the basic integrations. Okay, and then the matrix and determinants extra, that is probability statistics, then the other things like ordinary differential equation. It's important, but probability statistics, then this kind of things is not that much important. But next, coming to atomic and molecular structure. So basically from this you just need to study the whole quantum mechanics. For example, quantum mechanics, then the quantum mechanical operator, then linear operator, Hermitian operator, this kind of things. Okay, so basically quantum mechanics, then the uncertainty principle and problems with the Heisenberg uncertainty principles. Okay, so they make just ask to calculate the error in velocity or error in momentum. Okay, so this kind of things. So next topic, next chapter, or one more thing, that Pauli exclusion principle and the electronic configuration, which will be acceptable or which will not acceptable. Okay, so this kind of things. And another important, that is Schrodinger equation and the corresponding quantum numbers. Okay, Schrodinger equation and how quantum number came. So the number of radial node, number of angular node, and total number of node, the reference equations. Okay. Sorry. So then coming to theory of gas. Theory of gas, basically the number of equipartition principle, the energy equation, then the number of how to calculate the heat capacity at constant C, constant V, these kind of things. Then the kinetic theory means actually the variation of with temperature, variation of pressure, variation of molar mass of kinetic theory. That is Maxwell interpretation. Okay, Maxwell-Boltzmann distribution law, actually the three-dimensional distribution of the gas molecules. Okay, so this is important, and most important here is equipartition principle and then the compressibility factor like things. Okay, ideal and non-ideal gases. And one more chapter, most important chapter, that is solid state, that one problem, just do solve some kind of problems, density calculation, molar mass calculation, this kind of things, then FCC, BCC for these lattices. Okay, so one more thing, that is Bragg's law, Bragg's equation in lambda equals 2d sin theta. This equation is very important. Then heat capacity of solids, nothing you need not to read. Radius ratio rule, the basic theory, it's actually covered in inorganic chemistry, but here it's also present. Okay, and the corresponding which will be the size of the cation anion and the corresponding lattice energies. Then coming to chemical thermodynamics. From thermodynamics, just to read things like the isothermal expansion, isothermal reversible expansion, isothermal adiabatic irreversible expansion, adiabatic free expansion. So total the final equations. Okay, not anything, just final equations, and the basic theory, that is for adiabatic cooling, Joule-Thomson cooling, Joule-Thomson experiment, Joule experiment, this kind of things. Okay, and the basic equations, not the derivation. Okay, just basic equations, and then the relation between CP/CB and the problems regarding this, and to calculate the degrees of freedom. Okay, degrees of freedom means so heat capacity at constant C, constant V, and their interconversion. Okay, so suppose they gave you some CP value, so you should calculate they ask to calculate the CP value, constant pressure, the heat capacity, constant pressure, this kind of things. Okay, so of course the entropy, that is second law of thermodynamics, entropy and different equations. Just read the equations and remember the equations only, nothing else. Okay, just because it's revised time, so just remember all the equations, final equations that are coming out. Okay, so next is chemical and phase equilibria. So chemical equilibria means a lot of topics are present. So basically pH, then pH of proper solutions, the basic equations to solve the mathematical problems. Okay, because from here you will get some mathematical problems. Okay, so that is solubility from solubility product. Of course you know the final equation, solubility and relation between solubility and solubility product. Okay, and of course Kp, Kc, Kn, Kc, Kx, you know the relation between them, among them. Okay, And then coming to phase equilibria and phase rule. That is important for phase equilibria, the basic equations, that is F equals to C minus P plus 2, and the common things like other important topics like Raoult's law, Henry's law, this kind of things. And then finally colligative properties, that is the depression of freezing point, elevation of boiling point, then osmotic pressure, this kind of final equations only. Okay, and thus how can you solve the problems regarding this. Okay, then coming to electrochemistry and chemical kinetics, these are in one chapter. So this chapter is very, very important. From electrochemistry to solve the mathematical problems like potential difference, then potential calculation from chemical equation, Nernst equation, then some important things like galvanic cell, okay, and the basic theory, anode, cathode, the sign, because in JAM you will face some basic questions regarding all this. Okay, so just solve chemical equations that are involved in electrochemical cell. Okay, and to solve problems on suppose they may ask to calculate the number of equilibrium constant, to calculate from the delta G equals to minus NFE and delta G equals to minus RTLN K equilibrium. So equilibrium constant, then electrochemical potential. Okay, of course. So this kind of things you may face in JAM examination. And then is important topic is Arrhenius equation. This is very, very important regarding this collision theory, transition theory, chain reactions. From chain reactions you may face MCQ type questions, not the mathematical but the basic theory regarding chain reactions. Okay, then coming to photochemical processes, that is photochemistry basically. So Beer-Lambert law is important here, and catalysis, that is, these topics are not that much important for JAM examination, but you should read all this. But as it is revised time, so just read those topics which are very, very important. Okay, then coming to adsorption, that adsorption, from adsorption you will face, I am sure that this year you may face one question from adsorption, that will be the mathematical problem. So just to solve a lot of mathematical problems regarding the surface area of the stearic acid or surface area of other systems, other compounds. Okay, so whatever this is important for adsorption. And then coming to spectroscopy. So spectroscopy, I have already said the Beer-Lambert law. Then fundamental concepts of rotational magnetic spectroscopy is not that much important. Just read the basic theory behind the rotational, vibrational, electronic, magnetic transfer. And that means just the energy gap. Okay, the energy gap between these, all of these. So which is higher energy gap, which transition occurs in higher energy gap, which transition requires less energy. Okay, so then coming to organic chemistry, that organic chemistry, okay, so organic chemistry, from organic chemistry, just to solve problems like number of centers, RS nomenclatures, then what will be the number of stereoisomers present in a system, particular system, then aline biphenyl, the RS nomenclature of aline and biphenyl system, and the cyclohexane system of mono and disubstituted cyclohexanes. Okay, so just from cyclohexane system, do read this topics like E2 reaction in cyclohexane system, then NGP. Okay, this kind of problems. So this is from organic chemistry. Then coming to second, that is all the name reactions, then carbene, nitrene, benzene. So carbene, nitrene, I have provided already one notes on carbene, nitrene and benzene. So if you want to check, then check my previous videos, you will get, or you can check my blog. Okay, so you will get the link in the description below. So just name reactions, then oxidation reaction, I have already made a video on this, covered a video on this. And then Diels order reaction, that is of course in pericyclic types of reactions. So pericyclic is very vast chapter, so just you have to read all these. But if you have not read, then it's tough to answer from this topic. Okay, so just if you read, then it's okay, no problem. Pericyclic is very vast topic. Okay, so next coming to qualitative organic analysis. So the Nmr spectroscopy, UV-IR, because Nmr is quite vast, but UV-IR is very, very easy. So basically, to remember the IR and NMR value, different IR and NMR value, and the corresponding how to determine the structure and how to get the NMR peaks. Okay, this is very, very important. And then coming to natural product chemistry, terpene, carbohydrates. Okay, from these, just remember something like carbohydrates, amino acids, peptides, and nucleic acids. For this, one book is important. Solomon's book is very, very important. It's quite everything you will find in that book. So if you checked, then it's okay, no problem. But if you follow other books, so that's also no problem, because carbohydrates, so how are the conversion of projection, different positions, then the basic reactions, oxidation, then reduction, okay, nitric acid oxidation, this kind of things. Then amino acid to the protein peptide synthesis, then the C-terminal, N-terminal determination, this kind of things. Then peptides, of course, I have covered. Then nucleic acid, DNA, RNA structure, and the basic basis regarding all this. Okay, so last is aromatic and heterocyclic chemistry. So for aromatic, naphthalene, basic reactions regarding naphthalene, anthracene, and phenanthrene, and the other things like monocyclic, okay, other things like one heteroatom, the heterocyclic chemistry with one heteroatom, that is furan, pyrrole and pyridine, these kind of things. These three important heterocyclic chemistry. So you have to read all these, only three: furan, pyrrole and pyridine. These three one heteroatom heterocyclic chemistry. Okay, so now coming to inorganic chemistry, that says the periodic table. Periodic table, from periodic table, just it is here that the lattice energy equation, that is bond-length equation. Okay, then bond-Haber cycle, already covered in physical chemistry. So then phase shift theory, then hybridization. Hybridization is very, very important. Okay, so just do remember how to calculate the hybridization of a compound. Okay, so just do read these things. And then coming to main group elements. Main group elements is important because it's very vast topics, but do read the aluminium and boron system. Okay, because they have discussed here, provided one thing, that is the electron deficient compound involving main group elements. Okay, so that means boron and aluminium like groups. Okay, so read this system very, very carefully, and of course some hydrides, oxides, hydroxides, this kind of things. Already you can check my previous videos on this. Okay, so next coming to main transition elements. This chapter is the most important chapter of inorganic chemistry. So from transition metal, just read organometallics, carbene, nitrine, then carbine complexes, then of course the crystal field theory, very, very important. Okay, so then nitrosyl carbonyl, then the bent nitrosyl, bent carbonyl, the 18 electron rule, very, very important. Then the Color magnetic properties, that is the of course you know the Russell center coupling like things, then the diagrams. Okay, then of course John-Taylor distribution, is this topic is very, very important, John-Taylor distribution. Okay, then of course in spinel and inverse spinel structure. Okay, so these topics are very, very important. And bioinorganic chemistry, just to read the metalloproteins, the example of metalloproteins, the hemi group which consists of hemi group which doesn't. Okay, so these things remember. And basically hemoglobin, myoglobin, and one more thing, that is carbonic anhydrous, hemoglobin, and to read very carefully, very vast things they are. And along with this, the basic metalloproteins, example of metalloproteins, and which is blue copper protein, the examples. Okay, the metalloproteins and non-metalloproteins and their examples. And then coming to instrumentation and analysis. So just basic theory regarding conductometry, potentiometry, and nothing else. Nothing, you need not to read nothing over here. Just basic theory behind the conductometry and potentiometry. Okay, and the problem from these. Then is analytical chemistry, the last topic. That generally consists of acid base. So acidic and basic property, that is actually the complexometric titration. Okay, using EDTS. So just read the practical theory you have completed in your graduation, maybe second year or first year. Okay, inorganic chemistry practical I am talking. So the precipitation reactions, that means complexation reaction, precipitation reaction, the use of indicators, which indicators you should use, just remember the pH value of those indicators. Okay, and then use the organic reagents in inorganic analysis. Okay, organic reagents in inorganic analysis means glyoxime, then 110 phenanthrene, this kind of organic reagents that are used in inorganic chemistry to determine the inorganic ions. Now another topic is radioactivity and nuclear reactions and application of isotopes. So radioactivity and nuclear reactions, just to solve mathematical problems regarding T-half, how to calculate T-half, half-life time, then how to calculate the number of atoms left after this time of radioactivity. Okay, so the nuclear reactions, that is the alpha beta particles, which is alpha particle, which is beta, which is gamma, then their mass, their comparison basically. And then coming to other things like how to balance the equation, the nuclear equations by beta particle, alpha particle, and gamma particle. Okay, so or neutron. Okay, this kind of things. So I just here in this video I have just done some basic things that you already know, but just do revise all these things, because whichever I have discussed here, because these topics are much more important than the left. Okay, so just do practice. You have no time right now, so just do practice all this, and I will not take much more time. And just I will say just good luck for you, and see you again in IIT. Okay, so bye.